All right. Hi, everybody. Today I want to talk about exploit and intrusion automation and their consequences on security in the future, in the next few years. And I hope from this talk you're going to learn a bit what to associate with this word exploit automation, um, how exploit automation software can be designed, what it will do, and um, how you can use it. Okay. Um, First, to define the term, um, it's exploit intrusion automation means you have evaluation of remote server responses, which can mean banners, scan log output, or interactive querying, a tool that like queries a server for version information, queries to see if a specific thing is vulnerable or not, and then determining whether this matches a certain vulnerability in the database that you define, and then exploiting that vulnerability by using an exploit and verifying like that the exploit worked, and then doing other stuff and automating this whole process. First of all, I want to give you an idea how exploit automation can be designed, in what kind of software you're gonna find it, and for that I'm gonna demonstrate you my tool NEAT, which means Network Exploit Automation Tool. It's basically a tool I wrote for automating things like penetration testing, and that's actually the white hat part of it. Maybe you can imagine if you have a worm, there is exploit automation inside, like it automates the process of scanning. It then automates the process of determining whether there is vulnerability or not, and then exploiting and spreading. And the same process can be in penetration tools. There was my incentive for talking about this now was like I heard a few weeks ago that vulnerability that the first commercial exploit automation, intrusion automation tools were starting to be available, and there was like an article on Security Focus that said basically a tool that makes hackers obsolete, like half jokingly. So that was like a pre-announced release of the first commercial exploit automation tool for penetration testing purposes only. So this is it's a field that's interesting for white hats and black hats the same. Okay. I want to give you a short demonstration of my tool now, and then we're going to talk about the technology, and we're going to philosophize a bit about what the consequences are going to be, and we're going to have a little bit QA. But first to the demonstration. What you see here is like the command set of my tool. NEAT is basically smart script language. It's driven by a smart script language, which means it's fully configurable. You can like nearly 200% configure its behavior, but it's not like any other remote network language, because the commands are modular and specifically just for the step of exploit automation, just for the step of determining if whether a certain program is vulnerable, which means it evaluates scan logs. You have to scan before, then you parse it into a special format. You have a log file in a special format. You can use the scanners like banner grabber, or you just use a normal scanner and put it in the right format. The format is very simple. I'm gonna show it. You basically have it scans line by line. You have the host name, and then some kind of information. It can be any pattern. Usually it will be a vulnerability pattern. I mean a version pattern, and it will the initial behavior depends on that pattern. But you'll see that. Bigger font. I'll try. This is not my laptop, okay? But I'll try. I guess not. So basically you have you probably know this. This is like localhost, the left stuff. Like you have, on each line you have first the host name or the IP address, and after a short space, you have like any string that can be generated by a scanner or something like this. This is like the kind of input format that need users. It's not a very big format, but you're basically using some kind of script to change your scanner logs to look like this, and that's what it will do. Well, it will first take the host name and then save it into buffer, and then compare the left like the pattern with all entries in the vulnerability database. The vulnerability database looks like this. You basically configure all of this yourself. You have, damn, this is bad. Can we get it a little bit more to the right? No. Okay. Well, the first command is on every line is match. Like every rule is applied to every line, and you have like match, and then you have a string, an argument. If this line matches, then this rule, like each rule is one line, it's going to process further. And you have a set of commands, and all these commands are traversed, and this is basically how it works. When any command fails, then the rule is skipped and the next is applied, and this is basically it looks simple, but it's highly configurable, and it's very fast actually. So here are 3 examples of how you can use Neat. Basically, as a penetration tool, as I said, I think I'm gonna have to disappoint you because it is not going to be released anytime soon, which is something which I and my company agree on, because it's not my main focus project. My main focus project is company work. This is like a private project, and also it's there are issues of full disclosure and arms race and stuff like that, and I want to make sure that there's not going to be any problem for the security community, that it's actually going to help people and not cause trouble or anything. No, what? There are some important points. Neat is not a ROM toolkit. There are some functionalities like the core of exploit automation that is that somehow reminds you of worm functionality, but it's not a worm toolkit. It's a modular penetration testing tool, and you can basically, you can probably do a lot with it once you configure it. The commands are easy to add, like you're going to see. You can easily develop extensions for it, and there is no stealth or something like that, but I have a lot of ideas how you could actually put a lot of stealth, like polymorphic shellcode and multi-platform. And actually I talked to a few people, and like it seems to me like almost everybody who can code is like nowadays trying to write a multi-platform worm that will like destroy the internet, or at least try to. And I'm not going to implement that. So in our first example, we have this file. It's like a scan log. It's like 1127001, and then you have on the right side you have the patterns. Now this is like what we're going to work with. Like this is let's just say it's a scanner output. In example one, we're just using it as help for vulnerability evaluation, not using anything, not using any network connections. Basically, this rule set that you see here at the top, I don't know, can you see it? Again, every line starts with match command. It goes through a log file, or it can actually go through a lot of log files, and you have like one pattern for every exploit, and you see if it matches, then go to the next command, log it into a text, and that's like the most simple usage. You have like the commands match, log, and not, which is like an inversion of match. If it doesn't match, go on, and so I'm gonna try and demonstrate this evaluation. It will help, because if you have a scanner, you have like scan logs. It's usually a good idea to keep your scan logs as long as possible, especially if you're a white hat. If you're like auditing bigger network, and you find X vulnerabilities and like 100 vulnerabilities, and a year later there are going to come out a lot more vulnerabilities for the same system. You just have to scan it all again, and if you keep your scan logs, you just add one rule to need, and you re-evaluate the scan logs, and you have a small text file with vulnerabilities. So that's going to help you. So what I'm going to do now is run this test. I use rule base 1, which we used before, and it might not look so spectacular, but it's the concept of exploit automation is actually quite simple. But what you can do with it is a lot more. Like the concept of DDoS is like go into the multiple targets and hit one target. It's simple as well, but if you use your imagination, you can do a lot of, there's a lot to do. Not necessarily just negative stuff. So this was it, just scanned. And let's take a look at the output text. This is like vulnerable text. What it did was like evaluate with a match command and report every matching vulnerability from this raw scanner output so that it's verified. And you can do the same with network interaction, and that's actually what is NEAT all about. With example 2, we're going to evaluate scanner logs, see if there is any vulnerability, and if so, we're going to check the operating system version. Right now, this OS match command is implemented with backend with Nmap, which works pretty well, but it's a cheap implementation, but as long as it works. So if this matches, if you have the right version, if you determine it's vulnerable, you have the right operating system, then you're gonna try to commence actually an exploit. And all this, you can either go into interactive mode, which I do, so you can interactively use the shell, or you just go into fast mode, which means it's fully automated. You just let it run in the background and it will just go through all these rules, and after all you have like a file with positives where you have a backdoor installed or whatever you wanted. I'm just gonna demonstrate this. You see, it's like it makes a TCP connection, then sends the exploit and tries to connect it to a shell, and this is what I'm gonna show you. Need 2 dB is what you saw here, this with the OS match stuff. So now it will go through these commands. I think I'm going to show them again because the actual stuff goes pretty fast. So the commands at the top until end of rule base is like what it's going to do now. Usually you will have tons of edit exploits. I can show you a real database at the end, but I cannot show you like everything. So it will traverse these rules and do the exploitation when it finds something. All right. We can see the exploit worked. There's not much output. Like right now, I have a pseudo-daemon which emulates these clients. Like in this case, we determined bind A2 running determines the operating system as Linux and sends the right exploit for the right operating system, and it actually worked. And so now we have this shell command. You have like commands.txt where I put in like who am I and ID, and that's basically what it shows here. Now you have an interactive shell, or if you don't want an interactive shell, you don't have to. But basically, this is how it works. Now it's supposed to continue. When you press Ctrl D, it goes to the next host in case anything gets stuck, like here. But that's basically the principle. And you have also, if you look at the bottom, the first command there is TCP 66, TCP 21, and so on. You can use it as an active scanner, which means you don't match at all. You just have a list with hosts, and you actively scan and then evaluate. It's not very good for performance, but there are other things you might want to do it, like use it as a small fast scanner that exploits it afterwards. So these are the other commands. This is like currently the full command set. While it's pretty easy to add your own command, you have shell file or text, so it's match socks and win gates. It will bounce through socks and win gates if necessary, like to demonstrate that you have open win gates and what you can do with them. Like if you're gonna have to show that to a company, you basically have to show them everything, so everything is implemented, even the small stuff. TCP UDP connection will stay up as long as the connection stays up, or as soon as you issue a new one, and each of these connections just stay active for one world. So it's very stable. It can run for a long time through a lot of hosts and without any stability problems. You have log nap, which is just sleeping, exp is reading input and from the network and then seeing if it matches this pattern. You have writable, which is FTP writable scan, RPC. I implemented all the RPC calls to be able to include all the public RPC exploits, which was pretty painful, but it's possible to use direct RPC calls, and you have xfer, like for once you're connected to a shell, once your current script is connected to your shell, you can transfer files directly over the shell and stuff like that. So it's basically a little bit more than there are like small exploit automation tools. I wouldn't call them like that. They are out like in the underground for a few months, but they're basically just static shell scripts, and well, they're not as sophisticated as that, but functions like these, like you see in this list, are starting to be implemented, but it's mostly some exploits tied together by shell script. This is entirely C++, by the way. All right, let's see. No, that's like the technical side. That's like what I showed you is like one possible implementation of exploit automation. I bet there are lots of others, and as soon as like commercial tools, commercial intrusion automatic tools are going to get out, they're probably gonna look a lot different. But it's important for me to have this open source and release it as soon as this really starts, as soon as someone is going to make the first move into this direction. So like admins can actually use open source exploit automation and be as effective as in testing their hosts as the black hats or the kitties or whoever are. So once you have open source, a code base of open source exploit automation code, you can extend it, and you can do a lot of it, and when it will come out, it will be under GPL. So it's important that people start thinking about this and develop it further. I released some kind of text on my homepage which basically answers a lot of these questions. This is like the URL. I hate graphical presentations, by the way. This is like the URL, and I'm gonna show you the text, and so we're gonna do some Q&A after that, because I think maybe there are a lot of questions or a lot of misunderstandings about exploit automation, because it's such a new field or such small field right now, but it's going to become bigger sooner. So like I'm hope to try to clear some of the misunderstandings that are out about this. But first I wanted to show you the FAQ. So basically, what's the incentive for using automation tools right now? The answer to this is simply they are out already. There are like these kits. Commercial exploit automation is coming. Maybe there are some private versions out yet from company to company. I have no idea about that. And finally, there are worms, which are exploit automation essentially. In a very different form, in a simpler form, but you can write your counter tool. Like I think it might be possible that in a year or two, when these tools are really sophisticated, you make a contract with your security company, and the security company has like a contract with a list of contractors. It runs its own, it codes its own worm or a counter worm that runs and patches, and it configures it just to try to infect and attack potential actual clients that signed a mutual contract, and like doing this as a fast and convenient form of penetration testing and securing in one step. So maybe we're going to see counter worms. Well, the future will tell. how could intrusion automation tools possibly be designed? This is what like I was trying to show you right now. Um, as you see, there are lots of things, from a single application, monolithic applications that does all the stuff, to very modular. Basically, you see this enumeration. No, you don't. There's like 1, 2, 3, 4, 5, 6. This is like the cycle of an intrusion, the full cycle. 1 is searching for targets, 2 detecting security measures, 3 evading them, 4 target analysis. This is like all of the scanning. Then you have evaluation, when you actually have the patterns, the versions, and all the stuff. And 6 is active attacks, exploitation. 7 is inside the system privilege elevation, and 8 is spying, sniffing, abusing trust, spreading. Worms usually do the steps 1, 4, 5, and 6. They search for targets, they analyze the targets, then they do vulnerability evaluation and attack, and then they spread. And Neat does just steps 5 and 6. So that's why I say it's modular. It's just designed for these 2 steps and optimized to do them, and just written with a single intent to do these both steps, which are vulnerability evaluation, like database pattern comparison stuff, and attacks like running remote exploits and making sure they work, or if not, trying something else. The future goals of Neat right now I don't know, but it might there might be generally not this tool, or generally exploit automation tools might merge with like databases like security focuses, Bugtrack ID, or CVE, which is a great system which I use at my company all the time. CVE.org or cve.mitre.org. It's a great system, and like these tools might merge with convenient vulnerability databases. So you can you might be able to update them all the time and rerun them against your system when something new comes out. So you automatically secure or penetration test yourself, which makes it a lot easier to actually determine if you're vulnerable or not. Won't you be starting an arms race is another question. Oh, I don't think so, because it's already out. We have problems with worms. We have troubles with like little exploit kits or root kits with like automated scripts installed from like some IRC kiddies who are spreading them all through the planet. So it's already out, and the problem is right now this stuff is in the underground. Even if it's not sophisticated, it's not stuff that is open source, that is publicly worked on, and so there is already an arms race, and we can just make it better by getting this into open source and developing it. What are the benefits of keeping automation tools closed source? This is basically that it might not spread as fast and as wide initially, but eventually it will spread. Eventually everything will leak, like you had with maybe the first scanner IIS, and you can see this, okay. Everything will leak eventually, and then you have like an underground using a commercial closed source automation tool, and nobody, or it will be a lot harder doing an analysis than if the automation tool was there from day one for public, for everyone. So the benefits of keeping it open source might be that you have a sophisticated tool with, first of all, the intent to do it to design it for white hat tasks, and not to make it a point and click tool, like make something configurable and stuff like that. So it primarily the administrators and security people will have an advantage, because it's not that easy to use, but if you have enough knowledge, it's easier for you to use. So the black hats are in disadvantage, at least more of them. It won't primarily benefit the script kiddies for exactly these reasons, because it's a sophisticated tool, and it has no intentionally malicious features like stealth or like polymorphism, and it will be just normal exploits, unless you code some killer features into it. It will be just normal exploits, and it can be detected by a normal intrusion detection, just like you would detect any other public exploit. The legal details is it will be GPL. Once it's released, now I know it won't be that fast, but it's non-commercial release, but generally everything will be available. So what can you do against it is a harder question, but the prevention will just be, I guess, to spread these tools to the administrators, get the word out, and have actually people run the same tools that they are afraid that someone might use against them with an updated database system or something like that. That's like maybe a year or even more away, but that's how the future might look. That's how you're gonna protect yourself in the future, like fighting fire by fire. Are you saying exploit automation will be the next big thing? I have no idea, but it's a simple concept like DDoS or like distributed computing in general, but it's a simple concept but with a lot of potential. So maybe yes. Now I'm gonna show you. So you're not getting too bored. I'm gonna show you the configuration databases and everything in the full release, which I'm not going to spread anyway. So this is a full configuration database with added exploits and everything, few more commands. And this is like exploit database. I made something very simple here. I just made static shellcodes for every exploit, and you send them as one hunk. So I made sure that it would get the default versions, but not anything else. If you recompile already, you would be safe. But it's nothing you have to worry about, because you're not going to see this tool in the wild or anything. You can be sure it won't be out. So yes, I guess that's basically it. And now I'm waiting for Q&A from you. I think it will be the best thing if you come here up to the stage, grab the microphone and talk into the microphone. So if anyone has questions, then I'd be happy to hear them. There are no stupid questions. Well, maybe some.
Are you familiar with the buffer overflow in SSH that was discovered like 6 months ago? So this has a different character to most of the buffer overflows, so the attacks are different, right? Could you say something about the difficulty of automating exploits of that sort?
Well, I just want to make sure that you understand it. It's not an exploit itself. It's just a collection of public exploits which you run in a faster, more efficient manner, and it's it's different in that sense, because once something comes out, it will be put into a public database once you have these tools. But it's not like something, if something stays private, it stays private. But this is just, exploit automation is just a different method of commencing the actual exploit. So, did that answer your question? All right, okay. Any questions? Okay.
You say worms are also a form of exploit automation. Aren't you afraid if you release this program as open source that it will be misused as the basis of a new worm?
Basically, so many people are working on new worms. I'm not afraid that anyone. So there's so much out. So I think the difference is that worms are not automation exploit tools, but they contain this feature. It's like exploit automation is not a tool or an application. It's a technology, and right now it's a simple technology, but nonetheless, and worms contains this like with simple static rule bases. Uh, and need is something different. Yes, of course you could make a worm out of it, but you're gonna have problems because it's not designed to be this way. It's not stealth. It's not well, it's C++, but it's not designed to be very portable. You're gonna the way it sends right now is you're going to send a static exploit. Maybe you can send binary stuff and various things. You can make dynamic return addresses, but it's not designed to do like polymorphic shellcode or anything like that. You're gonna have no stealth features. That's something important. I didn't put any stealth features in. So generally the concept, of course, but this particular tool, I think people would rather write their own stuff if they wanted to write a real killer worm than using this modular thing, which requires a certain kind of scanlog input, scanlogs input, and certain kinds of other modular things to be present, and it's not optimized to be worm. But generally you're right. It's possible to write worms with the technology. Questions? No? Okay, then thank you.